Okay, we're looking at your FSA review packet, page 17. I'm going to start out with number 89. Again, if you collect letters throughout the video, turn them in with your name on it, and I could possibly draw your name to earn a special treat. The first problem says Samuel needs 233 feet of wood to build a fence. The wood comes in a length of 11 feet. Part A says, how many pieces of wood will Samuel need to buy? So this is feet to feet. I don't need to do any conversions. I know he needs a total of 233. He has 11. So how many pieces of, or each one is 11. How many pieces will he need to buy? So essentially, I'm taking the amount he needs and I'm dividing it by how much pieces come in each. So I'm going to take 233. And dividing by 11. 11 is close to 10, so if I needed to use that as a compatible number, I could. So about 10 could go into 23 2 times, and then just multiply. 2 times 11 is 22. That leaves me with 1 left, and I'm going to drop down my 3. It can go in one more time. And now I have a remainder of 2. So how many pieces of wood does he need to buy? Well, this would be 21 pieces, only that he still would not actually have enough wood. So he would need to buy another piece of wood to account for this. So he actually needs 22 pieces instead of 21. This is something that we wouldn't express as a remainder. He has to buy 11. So that is that answer. Look at part B. On part B, it says that Teresa needs twice as many feet of wood as Samuel. How many pieces of wood does Teresa need to buy? So Teresa needs twice as many feet of wood as Samuel. So the very first thing I'm going to do is take the amount Samuel needed, 233, and multiply it by 2. 2 times 3 is 6, 2 times 3 is 6, and 2 times 2 is 4. So this is how much she needs, and again, dividing it by the 11 feet sections, you're going to do 466 divided by 11. Again, your compatible number would be 10, so about how many times could 10 go into 46? Hopefully 4 times, and multiply it out. 4 times 11 is 44. 6 minus 4 would leave you with 2. Again, drop down your 6. How many times can 11 go into 26? About 2 times, which would give you 22. Again, this person still has a remainder of wood that they need, so instead of buying the 42 pieces, they're going to have to buy that extra piece to get those last 4 feet that they need, so they're going to actually need to purchase 43 pieces. And moving on to your next one, number 90, it says, oh, let me push that up. Oh, your first letter, let's go with an H. Your first letter is H. Nathan drew a design of a scalene and an obtuse triangle. Select all the figures that could be one of the triangles that he drew. So first of all, we need to know obtuse, and most of us know that we have acute, that's our little angles. We have a right, that's what squares off. And then our obtuse are the ones that are stretched out, kind of funny looking. They're not our normal triangles that we are comfortable with. And then this piece we have as a scalene. So if you remember before, we had equilateral, isosceles, scalene, and I told you to put them in ABC order, and that would tell you all are the same length, all of them are congruent, 2 are congruent, and none are congruent. This was also your hint for isosceles, that we have 2 eyes, so 2 angles for isosceles, 2 eyes on our face, right? So a scalene means it has 0 congruent sides, and it's got to be obtuse, so spread wide open. When I look at A, I don't see anything that looks like it would be the same length, and it is spread nice and wide open. It's greater than 90 degrees, because that would be my 90 degree. It's greater than that, so A works. When I look at B, I sort of think that these two look congruent, so this would actually be isosceles and not a scalene. When I look at C, certainly it is scalene. No sides are congruent. However, it squares off into a right angle, and I need an obtuse, so C does not work. When you're going to D, it's clearly an equilateral triangle because all 4 sides are the same length, so again, not a scalene. Here on E, again, they're noting that 2 sides are the same length, so it cannot be E. I'm actually going to go back to B. Since this one was noted that they're the same length on E, then I didn't actually see those marks on B. It was an assumption I made. Then they must be telling me that this one is not, so B works as well. This is your obtuse. This is obtuse, so those 2 are great. This is a right triangle. It won't work. This is acute because all sides are acute. This is acute, all sides are acute, and this has two congruent sides. Move on to, another letter, E. Write down the letter E. Move on to number 91. Miss Williams is organizing her office supplies. There are 3 open boxes of paper clips in her drawer. Each box has 7/8 of the paper clips left. How many boxes of paper clips are left? So you could certainly demonstrate this using a model, and you would draw your 3 hole. 1, 2, 3. And then you could cut it into 7. So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And you would shade in 7/8 on each of them. And then you could count how much you have all together. Or you could say, okay, 7/8 of 3, just multiply it. So 3 times 7/8. You're multiplying by a number less than 1, so your answer should be less than 3. So whole number times your numerator would give you 21. Your denominator would stay the same, of 8. 8 can go into 21 how many times? Let's see, 8 times 3 is 24, so not 3 times. It could go in 2 times. 2 times 8 would mean you're taking away 16, and you would have 5 8s left over, so 2 and 5 8s. But again, you could count that. You would get 8 8s by regrouping, and you would do that 2 times to give you your whole, and then you have 5 still left over. Now this one actually kind of makes a model too. I did a bar model up here. It does the same thing with a circle model. So I have 3 whole, and I'm going to have 7/8 in each of my boxes. See, I did bar model because boxes, right? Like totally, yeah. So you would, again, shade in 7 of your 8 on each one. And you could count. Doesn't matter where you shade, as long as 7 of them are shaded in each. And they did exactly what I just did above. 7 times 8 gave you 21. And then regrouping it into your whole, we had 2 and 5 8s above. 92 says complete the following statement using an option from the box that makes each statement true. If you'll notice, these are powers of 10, basically. So these are the ones that you're just using place value. The value of 6 in 26 and 495 thousandths is the blank value. So in what place value is this one in? And it's in times the value of this one right here. So this is in my tens place, and I moved from the tens place over to my ones place. So essentially it only moved 1 place value. It was in my tenths, and now it's in my ones place. So it is 10 as the value of, it is 10 times the value of this. I'm moving over 1 place value. Your other option would be to do like a comparison. So in this one, it's worth 6 and nothing. And this one here, it was in my tenths place. So you can see it was just 1 place value moved over. And in the next one, again, the value of the 3 in this is blank the value of the 3 in this. So again, how much is this one worth? This is in my hundredths place, so it's worth 3 hundredths. This one is in my tenths place. So the value of the 3 in 931 thousandths is blank times the value of the 3 in 384 thousandths. So you can see what it had done is it had actually gotten smaller. If this was the value that we're comparing it to, it had gotten smaller. So instead of getting bigger, it's going to get smaller. So I'm not multiplying by a whole number. I'm multiplying by a number less than 1. I moved over 1 place value, so my answer for this is 1/10. And your last letter for page 17 is the letter R. And turn that in.